and several others. They were pretty much the same level. But
on the same level for the compression rate or the speed? Because
I was more concerned about speed. Compression, let's say, they might stick with 20%, 50%. But for me, the challenge was speed.
okay. No, because SFO is said to be one of the fastest compressor and the looping.
Also, at the low, it's had to be optimized for speed.
It's optimized, but the algorithm underneath is much more complicated.
Yeah, and that's maybe what I'm discovering, that I can use something simpler. That's
Yeah.
Thanks. Anyone else? Okay, thanks. Then I guess we get on to the more. Sorry, something online?
No, someone just stopped the meeting up there. So I've started it again, but it's not visible. Yeah.
Okay. That's annoying. I'll call the conference. Yeah. Sorry about that.
I don't know. Is it the conclusion? Well, I think on your V2, we go discussing that with when we discuss later.
Okay. It's not blue games. So then it's more than we also want to be clear with the sanctions.
But having several compressor threads, regardless of it's that we device or not, whose direction right into the HDF file. You tried it as the work?
No, I didn't try it, but I suppose that this kind of like a compact system to me didn't seem to.
If you have the HDF writing pre-compressed chunks, well, that's what Thomas has in his slide. It's well, not here to blame HDF5, but writing through the complete HDF5 mechanism, which checks everything, is very slow. If you just compress on your own in a single thread and write using direction right, you'll be faster than the HDF5 library. If you compress with several threads and write sequentially later on, assuming that your hard drive or SSD is fast enough, you can easily outperform what you get in an easy way via H5 plus HDF5 library.
I mean, I would try possibly to make my compression more relevant or speed the work with separate images. And then in the end, right.
Recording in progress.
This is what Dex is doing. This is what we are doing at ESRF. It's done at several places, and the same solution is used at multiple places.
Yeah, this I completely would expect, and yeah, I don't know if it means that there is something I can leverage, because let's say I would not do the run length encoding. If I would pass 1 megabyte of images, is there then, you say, an available library that is happy to accept those, not continuous in memory, like I have separate places for the images, and then run on different threads, and in the end, do the writing? Yes, but my challenge is that at least this could be also a Python artifact that if I, like for the chunking, I think, if the, or some, I mean, I haven't figured out exactly where, but to me it seems like there is a performance issue by giving big data to the compressor, even if the output is small. Because otherwise, I mean, you could see the file sizes before, that the file size is only a factor 2 different, but the speed is a factor 3 of.
Yeah, but if your chunk, I would start easily with having 1 frame per chunk and compress, let's say 1,000 chunks in a file, something like this. And well, that's something that we are doing every day at Synchrotron Sources, and it kind of works.
Yeah, but this is when you do the direct write then, I think. And so far,
Yeah.
I didn't know about that until yesterday. So.
Yeah, but the direct chunk write is the solution if you want to go fast, because unfortunately at the HDF5 level, well, not unfortunately, but for safety, they are checking everything that goes in to validate that they can write. If you bypass all this and you do a direct chunk write, and your chunk is properly pre-compressed and nicely shaped to fit what HDF5 library is expecting, you get several thousands of frames per second to be written to the disk. That's with 1 single thread. But then you need to produce the compressed data, the compressed chunks at an acceptable rate, of course. I'm not willing to blame HDF5. It's
No. Actually, what also will help, I think, and then it will correct me, if HDF5 expose, for example, they use multi-threading to compress chunks with different threads using their capability. And then they provide to HDF5 library array of sizes and coordinates. So HDF5 can expose, can pre-allocate those chunks, and then return in return for this array, return where to write, and they do parallel write. It will speed up a lot. And we're supposed to have something in the library internal, so if we have public API, it will speed up their processing a lot. No, after you finish compressing.
Okay,
But what HDF5 library need to know, it needs to allocate space and tell you where to write. When you're doing it with 1 thread, it does it for you and it does it internally. But to use multi-threading outside, until we have this, what we're implementing now, this will be, if you have API that returns you locations where to write, you can use multi-threading to write. And this probably will not be very hard to do. There should be function already.
So did anyone else want to comment? Okay, thanks. So we can continue.